Have you ever stared at one of those maps with all the squiggly lines and just wondered what on earth they're trying to tell you? Well, today we're going to learn their language. And seriously, by the end of this, you'll be able to look at a flat piece of paper and know exactly where water's going to flow across the land. It's a pretty cool skill. So let's get right to it. So I want you to think about this for a second. Picture a single raindrop falling from the sky. When it finally hits the ground, where does it go? Does it trickle to the left? Maybe rush off to the right? You might think it's totally random, but it's not at all. That raindrop has a very specific path it is destined to follow. So how in the world do we follow that little raindrop's journey? Well, it all starts by decoding the secret language of the map itself. Okay, so the most basic word in this language is the contour line. And it's actually a really simple idea. Every single point on one of these lines is at the exact same height. You can almost think of it like taking a giant knife and making a perfectly level slice right through a hillside. That slice is your contour line. Now, these lines follow three really simple rules that tell us pretty much everything we need to know. First up, the numbers tell you the height. So yeah, 27 meters is obviously higher up than 23. Second, look at how far apart the lines are. If they're all jammed together, you're looking at a steep hill, maybe even a cliff. If they're spread way out, that's a nice, gentle slope. And of course, the most important rule, thanks to gravity, water is always going to flow downhill, from the higher numbers toward the lower ones. And that brings us to the single most important idea for figuring all this out. If you remember one thing, make it this. We call it the golden rule of flow. Okay, here it is. This is the big secret. Water always flows downhill, and it does so perpendicular to the contour lines. That's it. That one word, perpendicular, is the whole key. It just means that water is going to take the fastest, most direct route down the hill, the steepest path. It's going to slice across each of those contour lines at a perfect 90-degree angle. And this slide just shows it perfectly. Take a look at the path on the left. See how it hits every single contour line at a sharp 90-degree angle? That's the path of steepest descent. That's our raindrop's real journey. Now look at the path on the right, the one that's kind of slanting across the lines. Water just doesn't do that. Physics doesn't work that way. Water is lazy, it's efficient, it doesn't take some leisurely diagonal stroll down a hill. All right, so now that we know the golden rule, let's actually put it to work. It's time to trace that water's path for real. Let's follow our little raindrop right from the top. You can totally do this yourself. It's a simple 3-step process. First, just pick your starting point on a high contour line, maybe that one marked 27 on our map. Step 2, start drawing a line down toward the lower numbers. But here's the crucial part. Make sure your line crosses every single contour at that perfect 90-degree angle. And finally, just follow the path all the way down. The line you just drew, that is the exact route that water is going to take. So if we look at our example map here, a drop of water that lands up near contour 27 in the top left is going to travel perpendicular to each and every line. It's going to make its way, step by step, across the landscape until it gets down to the area around contour 23 in the bottom right. See? It's totally predictable. It's not random at all. But wait, the map can tell us even more. We know the direction of the journey now, but what about the speed? We can actually get a sense of how fast that water is moving by calculating the slope. And we can do that with a pretty simple formula. The slope, as a percentage, is just the vertical difference in height divided by the horizontal distance across the map. Then you just multiply that by 100 to turn it into a percentage. Easy. So let's use our example, right? The water drops from 27 meters down to 23 meters. So 27 minus 23, that's a vertical drop of 4 meters. Now, let's just say the horizontal distance on the map that it travels is 40 meters. So we take our 4, we divide it by 40, and then we multiply that result by 100. And what do you get? A 10% slope. So what does that even mean? Well, in the real world, that's a pretty moderate downhill grade. We're not talking about a sheer cliff face, but it's definitely not flat ground either. Our little raindrop is moving along at a nice, steady pace. Think about what we just did. We just figured out the character of an entire landscape from a couple of lines on paper. How cool is that? So let's just take a second to appreciate the superpower you have officially unlocked today. You can now look at a totally flat map and see a 3D landscape of hills and valleys in your mind. You can instantly tell the difference between super steep terrain and a gentle, rolling field. And the best part? You can predict, with confidence, exactly where water is going to flow. For anybody from a hiker to a farmer to an engineer, that is a genuine superpower. Which really just leaves us with one final question. You've just learned to read the world in a brand new way. The next time you're outside or even just looking at a local map, all those lines and shapes are going to mean something totally different to you. So now, what story does the land around you tell?